Hello everyone, welcome back to Coding Intuition. Today we are going to solve longest cycle in the graph problem on LeetCode. So let us just firstly understand what is this question is trying to say. So in this question we are given an array of edges, and then an array of edges basically represents this graph. For example, we take this example. The zero has an edge to 3. So basically we can see this edge. And one more important thing in this question, we have directed edges in this question. So we can go from 0 to 3 but cannot come back from 3 to 0. All the edges are directed edges. Now another important thing is that we need to calculate the longest length of cycle inside this graph. For example, inside this you can see we have a cycle. Cycle is basically you start from one node and come back to that node again. Basically will form a cycle. So there could be multiple cycles inside this graph. For example, we have another nodes like this and this, and they again come back to 0. So that will form another cycle as well. So there could be multiple cycles inside this graph, and we need to calculate the length of the longest cycle inside this graph. So that is what question wants to do us. So I hope that makes the question very clear. Now let us try to understand the solution for this. So one very obvious intuition comes inside the mind when thinking about this question is that we will be needing to traverse the graph in order to identify any cycle in that. So for traversing the graph in this case, we will use depth first search algorithm. And in depth first search algorithm, while doing the depth first search over this graph, the fun thing to notice is that it is we have directed edges in this graph. So if we, for example, start from 0 node and if we traverse this graph, we will move to node 3, 2, 4, and again come back to 3. But we will never go to node 1 if we start from node 0. So one thing we need to do while doing the depth first search, we will need to iterate. We will need to have a loop to iterate over all over our nodes, and we will check if they are already visited. We will not do the depth first search over them. For example, in this case, firstly we will do depth first search over 0. After doing depth first search over 0, we will mark all the node we have visited. All the node we have visited, we will go to 3, then from 3 we can go to 2, from 2 we can go to 4, and from 4 we can go to 3. So then we will mark all these nodes as visited, but our 1 will be remaining, and there might be a case where are some another edges from 1, and that may be making more bigger cycle than this. So we will be also be needing to consider that. So for that we will iterate all over our nodes and do that first search over unvisited nodes. Okay, so first step is to do this. Now as we do our depth first search, we need to calculate the length of our cycle. So to calculate the length of our cycle, let us just keep track of the distance covered by us from starting to wherever we are going in the depth first search. So let us just consider the distance traveled by this node is just 1, and after we come here we will say we have to travel the distance of 2. Okay, in that first search. After this node we will obviously move to the 3 has only one edge to 2, and we will move to 2 then. So let us say this has covered the distance of 3. Now we will move to 4, and let us say this has covered the distance of 4. Now as soon as as soon as we come back to this, we know that we have formed a cycle in this case. So as soon as we come to 3, we know that we have formed a cycle. Basically we will check if we have come back to a node which already have an assigned value for the distance, and it is already visited as well. So basically we if we come to a node which have already assigned value for a distance, in that case what we will be doing is we will be subtracting a distance from its parent node. Okay, so let me just give you an example here. um, from its parent node. So here we will be doing 4 minus 2. Okay, so what we are doing here is we are subtracting the distance of this length from 0 all up to 4. Okay, so and we are subtracting this from here. This distance covered by this node has to be subtracted because that doesn't include inside our cycle. This red arrows represents the cycle, and this distance we need to subtract this extra distance. So that is what we are subtracting, and we also need to calculate this distance. So we will add 1 to it. Okay, so that will give us our length of our as soon as we have add 1 to it, that will give us the length of our cycle to us. So 4 minus 2 is 2 plus 1 is equal to 3. So we get the length of our cycle, which is 3. We have 3 nodes inside cycle, and that is what is our length of our cycle. So that's how we will calculate the length of the cycles. Every time we will calculate the length of cycle in whatever cycle we are going. How we will be identifying that that cycle has formed if we encounter any node which already have a value of distance. That means that this node has already been visited, and it now it is forming a circle. So that's when we know we are formed a cycle, and we there could be multiple cycles inside our graph. So we will check for all of them, and will keep the maximum amongst them. and that's how we will calculate the length of the maximum cycle inside our graph here. So let us just move to the code. So now we are inside our code. So let us try to understand with the code and with some examples here. So first of all, we have given an array of edges, basically representing a unique edge for every single node, because there are nodes from 0 to n minus 1. In the example we have considered, we have nodes from 0 to 4, and we have unique indexes, so each index have only one child, basically, in this case. So we have an array of edges. We will use this to iterate over a graph and do that first search, and we will create a boolean array which will represent if the current node is visited or not. It is also the same size of as of edges. Okay, so we have created a boolean array. Now we will check if the current node is not visited. So we will start from I is equal to 0 to last each and every node. We will traverse, and we will use another map to keep the distance of each node, keep the distance traveled by each node. For example, the 0th node has traveled some one distance, and then 3 node has traveled distance 2. So we will keep the value of node inside our key, and the value of distance traveled by it inside our value. So and we will put that in another map. Now we have initialized the value of our node. We are starting with to 1, and now we will start our depth first search algorithm. So as soon as we enter our depth first search algorithm, first of all we have passed this parameters edges, visited array, and our distance, and distance are another map, and the node we are starting with. We are starting with ith node, which is basically 0 in this case. When we are starting, so first of all we'll mark our current node to be visited as uh, that are visited now. So now we will as it has only one edge, so we will consider its neighbor. So we will, as in this example, we will move to 0 to 3, and as we have moved to 0, we will check if its value is minus 1. Sorry, I forgot to mention that if any value inside the edges is minus 1, it represents this node have no child, basically this node have no neighbor. So we don't have any neighbor for this node. Okay, so that is when we mark it as minus 1. Okay, and we will check if it is not already visited. We will visit that node, and we will mark the distance traveled by it. The distance traveled by it will be 1 plus the distance traveled by its parent. So from the distance traveled by 0 was 1, and now the distance traveled by 3 is 2. So that is what we are doing, and now we will call the fs recursively and do the same thing for our node 3, and we'll keep doing that until we find out a node which is already visited. So if we have a neighbor which has not the value 1, and the visited neighbor will obviously be true, that's why we will come in else, and we'll check if it has already if it has already assigned a distance to it. Basically, we have already assigned a distance to it, and then we will find our answer using this formula that we have seen inside on the whiteboard, that we have to subtract the distance traveled by its parent and up to the current its parent, and up to the our neighbor where we are currently right now, and we will subtract that distance and add 1 to it to get the length of the cycle, and we will calculate the maximum of it as we are iterating all over our nodes, and there will be multiple cycles inside our graph. So that's why we are doing this. So that is the code for this. I hope this had made the explanation very much clear to you. So thank you so much for watching. Bye bye.